Okay, so now we are officially recording. Thank you all again for joining us at today's Research and Review webinar, the first of this academic year. We are so grateful for Joseph J. Williams to be joining us to talk about cognitive science and its intersection with online learning. First, a brief introduction of Joseph's work. Joseph J. Williams is a researcher and consultant in cognitive science and online education. His academic work consists of cognitive science research to understand how people learn through experiments or A/B tests, construction of assessments, and statistical modeling. His practical work consists of consulting to improve and evaluate learning from online educational resources, such as edX videos, K-12 text lessons, and Khan Academy's interactive math exercises. He is currently at Stanford University in the Lytics Lab of the Office of the Vice Provost of Online Learning and at the Graduate School of Education. He received his PhD from UC Berkeley's Psychology Department in Experimental and Computational Cognitive Science. Again, we are grateful that you are here to talk to us about your work, Joseph. I'm going to go ahead and hand the mic over to you.
Okay, is everyone hearing me properly? Is that coming through, Catherine? I just want to check the sound.
Yes, we can hear you.
Oh, you can hear. Okay, great. Cool. Okay. Well, hi to everyone. Thanks a lot for coming. And I'm sorry I had to bore you with so much details about my life. I wasn't sure exactly whether the bio would be read out loud or not. So one thing I'll mention right away is that I have a bit of a hoarse throat, so feel free to message if you'd like me to slow down or speak more clearly. And I'm also originally from Trinidad, so you're going to have to work through an accent. I naturally tend to speak fast, and someone with an accent sounds like they're speaking more quickly, so it might sound like I'm speaking 4 times the normal presenter, but I'll try to slow it down. And so what I'll talk a bit about today is how we can improve online education resources using cognitive science, and also the reverse. How can we sort of take the insights that teachers and people who work in real-world environments can provide to scientists in terms of what kinds of questions about education could we be examining, or what insights could we have about how to improve learning. And so as Catherine mentioned, I'm at Stanford as a research fellow, and my approach is to try and act as a knowledge broker. So there are thousands of papers that have been written in psychology and cognitive science and learning sciences, computer science, education. So how can we sort of take a lot of that literature, which is often quite academic, and translate into practical tips or implementations that can actually be used in a real-world setting? And the reverse also. How can we do further research that's guided by the kinds of challenges and insights that teachers have about teaching? And I think online resources is especially a good way to do this. So I'll start going through the slide. Just to check, I'm moving this kind of laser pointer around. Do people see that? Catherine, can you see the laser pointer moving?
Nope, we can't.
Okay, but if I click, now you see it.
Oh, yes, now we got it.
Okay, so every time I click, it's going to show up. Okay, great.
Perfect.
Sorry, you have to, everyone's learning all the time. I'm learning to use Blackboard right now. Okay, so one question I think that's really worth asking is, what's different about online education resources compared to how we've been doing education for the many years before or doing in the classroom? And of course the answer is there's a lot. I won't get into all the different things. Many of you are probably already familiar with it. One thing I think I should clarify, at least in terms of scope, is that when I say online education resources, I'm thinking specifically about sort of small units of content. So for example, if you're teaching someone from a video lesson between 5 and 20 minutes, if you give them a page of text to read about chemistry, and also exercises. So if someone's solving a math problem, or if someone was trying to do some kind of writing assignment for literature. And so I'm really focused at this kind of very small unit level, which are the kinds of building blocks of bigger courses, for example. And so what I've been thinking about is when you take something that's in the real world, like a student working on an exercise in their paper book, and you move them into this online environment where now they're doing an exercise but it's on the computer. What is it that's sort of change? It's a pretty simple step to go from physical to digital, but what does that buy us? So what does it provide? So I think there are a couple of things that I'm going to focus on. One is that it aligns scientists and educators a lot more closely. So if you think about this environment on the left, which is a classroom, and this environment on the right, which is a laboratory, for example, where psychologists have people come in and do studies or experiments on the computer. These often don't overlap that much. We can really have good control here and get people to do tasks and make them try different versions of learning materials, but it's very hard to get a teacher to show someone two different versions of instruction. And there are not that many students that we can experiment and try out different versions of instruction and see which one works. It's also really hard to collect data. You have to grade everyone's assignment by hand. But what I think is special about online learning is it kind of moves these two environments into one space. So that simple girl working on a computer is now a mixture of a laboratory and a real-world setting. It's an actual resource people are using. And so what this means is that now scientists and educators are a lot more closely aligned. So we can think about how do we make practical improvements to resources like online videos or online exercises, but also how can we do scientific research? So how can we ask new questions about how people learn and figure out ways that we can improve learning? So in addition to bringing science and educators together, another thing that I think maybe hasn't been emphasized as much is that online learning resources, because they're digital, they're really easy to change. They can be, you can make a copy of it, you can add, you can phrase an explanation in different ways, you can add questions, you can make it interactive. And the idea is that you can repeatedly do this and try out different variations until you get a really high quality resource. And this is something that's a lot harder to do with a physical resource like a notebook. For example, you could have 10 teachers sit down and all look at a math exercise online and make their different versions and just re-upload them. But with a physical notebook, it's not as common to do that. A related idea also is that when a resource is online instead of in paper, it really facilitates collaboration. Because to work on something together, let's say I was working with one of you on trying to create a really good math exercise for learning algebra. I would have to be in the same room if it was a paper result, or do a bunch of emailing back and forth where it's being scanned. But with an online resource, anyone who has access to an internet connection can look at a resource, comment on it, make suggestions. They can do it asynchronously, so we don't have to schedule time, and they can do it at their convenience. Are you hearing me still? Okay. And so in a way, I think...
Yeah, you're coming in fine. If somebody's on the phone, if you could mute your phone, that will help the rest of us. Thanks.
So what then is really exciting about online education resources, in a way, hasn't even begun to happen. Because I think some of the strongest elements or greatest benefits are actually that they're a lot like Wikipedia. Wikipedia was pretty simple when it came out. It wasn't a resource that could really compare to Encyclopedia Britannica. But because over time, people can keep improving it, and you have a wide variety of people adding to it, it's now such an unparalleled resource for knowledge that encyclopedias are not really in business anymore. So in a way, if online education resources like math exercises or videos, if they're the kinds of things that need to be constantly improved till we get the very best versions and then we can disseminate them to anyone, anywhere, we actually might expect that most of the benefits of online learning will actually come over time. This is especially true because a lot of the scientific research that we can conduct with online resources is something that's only now beginning. Any questions about that? Okay. So in terms of the topic that I'm going to just give an overview, this is going to be a bit of a fire hose. So I'll try and throw a lot of things out to see if they jog ideas or they're parts you might connect with. And I suspect, if you're interested in applying this in a classroom, you're probably going to be revisiting these slides anyway. One thing I actually should have highlighted is, because I believe in online education, I actually put these slides up in this document, tiny.cc/InnerCall webinar. And so you can see the description of the talk, the slides and all that. So you can always just go and revisit them there. I have my contact information there as well. And I'd be happy for sort of advice you have on improving these ideas or ways you think it will and won't work, anything at all that you might want to chip in with. So you can always come back to these slides when you're ready to use them. So in terms of the fire hose, I'll throw a bunch of things out, but I think the main takeaways that might come out of this is whether there's some relevant ideas here from cognitive science that you might be able to find online learning or that you might think would help you in choosing which resources are good. And also, how can we sort of do more effective collaboration between scientists and educators in terms of trying to improve the quality of resources? Okay. So I'll first talk about applying cognitive science to online learning. And this is really a mixture of talking about previous findings, because there have been thousands of papers published, and also experiments that are in progress right now, or I've recently completed, like my own research. The first issue is, well, how do we increase motivation of students who are learning online? Another is, how do we increase learning without actually changing materials? So it's really hard to do curriculum development. But the idea here is by asking questions, or inserting questions into online environments that prompt students to answer and explain, we can actually increase learning without actually changing the underlying materials. Another issue is now is we're always interested not just in teaching one concept, but actually learning strategies. So look at one attempt to do this. And then finally, kind of combine the previous points about motivation and learning strategies. It's going to look a bit on some attempts I've been making to provide lessons that teach students beliefs that intelligence is malleable, increase motivation, and also teach learning strategies in order to look at what's the interaction between them. Then I'll talk about what I think the value might be of online collaborations between scientists and educators, because the amazing thing about the internet is not just that it has online resources, but it really facilitates the spread of information and connecting people. And so this is one thing that I've started at Berkeley and I'm interested in sort of scaling up in terms of finding a way for people to connect and share sort of practical advice and information about education from different perspectives. And then also some criteria for what are the kinds of online learning resources that are really friendly towards research, that make it really easy for researchers and practitioners to work together. Maybe they're resources you use, or maybe they're criteria you can keep in mind when you're sort of choosing between options or developing something of your own. Okay, so in terms of reviewing and synthesizing cognitive science research, this is one paper that I've written that's kind of representative of this work, where basically I look across a range of publications and try and choose what are papers that are really relevant, and then how can I actually spell out the practical implications. So this paper actually talks about how we can improve motivation and ask the questions as applied to a particular video or exercise. If you had a math exercise from Khan Academy, or you had a video off of an online course, how can you improve learning from that video? This is also some work that's in a different area, which is a review paper that considers even broader range of ways to enhance memory and learning. And this is a reference list that might be useful. Basically, I've had to read at least 2,000 or 3,000 papers on learning science and education and psychology, and they were valuable. But this is, in my mind, the 10 or 20 papers that I wish I'd read first, that I kind of started with, because they apply broadly and they sort of had some really foundational principles for me. And feel free to make suggestions. Also, with respect to reviewing and synthesizing, it wouldn't be sensible to not acknowledge the great work that's been done before in doing that. In particular, in this paper and in this reference list, I talk about a couple of resources that also synthesize and aggregate, and also how they're a bit different. I focus a lot more on online learning, and when people talk about cognitive science is so broad that you can take 5 cognitive science researchers who are applying it to education, and they'll be doing 5 completely different things that might be quite complementary, but they'll be focusing in very different areas in space. This person, Daniel Willingham, is a professor at the University of Virginia, and he's just produced some really excellent work in terms of, again, looking across thousands and thousands of papers. He's a lot older than me. He's been able to see a lot more. And he's a full-time writer working on this now. So why don't students like school? It's Lessons to Cognitive Science for Teaching. And that's a fantastic book in terms of reviewing some main principles about how to improve teaching and learning. And I actually found, everyone's busy. Listening to the audiobook was actually quite pleasant. You really get the main ideas. He's also put a really good recent book, which is When Can You Trust the Experts? So how do you tell good science from bad in education? The one way, of course, is to be in contact with researchers, but he also provides a nice perspective on what are some good tips you can use, and some more background on what the kind of approach your researchers are taking in education. So in terms of review and synthesis. So in terms of getting down to a practical issue, so how do we increase motivation? So if you were to take a second and think, if you had a bunch of students in a math class learning from online resources like videos and math exercises, how do you try and motivate them to work harder? Because often they're on their own or they're sort of separate from people, especially if they're doing work at home through an online setting. There's a real risk that people just won't be engaged. So I'm sure you people listening have come up with a bunch of great ideas. And there are many ways that you could think about increasing motivation. The main challenge is there's so many of these things that we tried in the past and we're not actually sure how big of an effect they have. So what I did is synthesize and look across literature that's been conducted on how to improve motivation. And one thing that really jumps out is a kind of counterintuitive idea. If you change students' implicit beliefs about whether intelligence is fixed or malleable, this actually has a huge effect on their motivation. So not necessarily promising them rewards or raising their self-confidence. But the idea here is maybe illustrated well by these kinds of statements. So just do a task for a second. On a scale from 1 to 10, how much do you agree that your intelligence is something very basic about you that you can't change very much? Versus, no matter how much intelligence you have, you can always change it quite a bit. So what these do is reflect a fixed mindset versus a growth mindset. So students with a fixed mindset see intelligence as something like the length of your bones. It's just an inherent property of you. Students who have a growth mindset think of intelligence a lot more like a muscle. When you exercise it, it gets stronger, and so it can improve with use. Now, what's interesting is that it's kind of intuitive that if you think intelligence is malleable, then you're going to work a bit harder. But what's amazing is just the size of this effect. So it becomes a self-fulfilling prophecy. If you think intelligence is fixed, well, every time you're doing a problem and you're struggling, it's a pain. You just feel terrible about yourself. To you, it's evidence that you're down. So you're avoiding comfortable challenges. On the other hand, if you have a growth mindset, well, it's actually not that big a deal to be struggling or have a hard problem. What it means is, well, I don't know how to solve this now, but actually there's an opportunity for me to learn something. So you're sort of anticipating that progress. Another point is you avoid asking questions because showing that you don't know something is just reflecting on your lack of ability. Whereas if you've got a growth mindset, you're happy to ask the question because it's fine to not know something because you're about to learn it. And you're also much more likely to examine your mistakes. When you get a problem wrong in class or when someone points out something you could have done better, you see it as an opportunity to learn. And so this finding, it's been done in sort of over 30 years of research by Carol Dweck at Stanford and many other collaborators. And this is an area I've started working in recently. And it's been found to correlate with all kinds of measures of students' outcomes. Now, the really interesting idea here is, can we do experiments that use ideas from this motivation research to boost students' learning? And so the experiment I'm currently conducting now, I actually have some preliminary data, but because this is a public forum, I actually can't show the data before it's been published in a journal, so sorry about that. But I think this will give you a good sense of the kind of work we can do with online resources and how it can actually help students in your classroom. So the experiment I'll talk about is, how can we use this motivation research to boost students' learning of math online in Khan Academy? So I think many people have heard of Khan Academy, but basically it's a website where they just have hundreds of thousands of students going online to use these free videos and also these free math exercises, which maybe isn't as prominent. So there's 300 different, 500 different kinds of math exercises from algebra to geometry to trigonometry, where students attempt them over and over. And this is what I actually really focused on because it provides a really good measure of learning. If students are watching a video, it's hard for me to know exactly what they're learning from it. And so I think this experiment I'll discuss outlines the kind of approach that I try to take when I'm linking research with practice. So the first part is, how can I identify a real-world resource? So it's kind of like a product. I mean, it can be free, but the product in the sense that it's something you can give someone and they can use immediately. It's not like a little piece of a curriculum that can't stand on its own. It might be a part of a curriculum, but it's also something that someone can just click on the URL and go and use. And so in this case, the resource I focused on was math exercises on Khan Academy. And then I try and think, well, what are the outcomes that they care about improving? Then I attempt to figure out, well, what kind of research has been done, out of these thousands of papers that might have recommendations for the outcomes that Khan Academy cares about. And at the same time, I'm thinking, well, I want to figure out and how do I help an online learning resource or provider like Khan Academy by improving their outcomes. But also I'm thinking, well, scientifically, I have to do research. That's sort of my job. It's what really excites me. So how can I ask a new theoretical question at the same time? So we're trying to, think win-win, as is a very popular kind of, business slogan these days. And then that leads to an experiment where I actually try and evaluate, are these synthesized recommendations actually going to improve those outcomes? And that's what I'll discuss in the upcoming slides. Any questions so far? How is my speed? Are people losing me? When I gave a...
Yeah, Joseph,
it's okay?
Great.
When okay, great. When I actually, I gave a Google tech talk and it was recorded and put on YouTube. And I know YouTube is just infamous for comments, but I heard some hilarious comments in the feed about people not having any idea what I was saying. So just want to check in. Okay, so in terms of the first part of this approach, learning from math exercises, here's a sense of what a typical exercise looks like. And what's nice is this is not just common to Khan Academy, it's pretty widespread. You state a problem, like give someone a stats problem, then they've got to type in their answer and they can check it. And if they get it wrong, they have to keep trying until they get it. So they can't go forward until they get it right. Now, of course, if students can't figure it out, they can ask for a hint. And when you click on a hint, it's pretty simple. It just shows your solution step line by line by line until you get to the answer, which you can always type in. So it's not like an adaptive hint, but it's a way of sort of, the solution's there, people need it, but you don't show it to them until they really have to. So in terms of what Khan Academy cares about maximizing for these kinds of exercises, and what many teachers probably do too, well, if we want to increase motivation, how can we increase how many problems students are going to complete? And then how can we increase what percent of those problems they're getting right? If they try 20 problems, how many of them do they actually get right? If they're really learning in a deep way, you expect that that's going to increase over time. Or you expect that anything I do to apply scientific research should be increasing accuracy. Okay, so the next step in terms of synthesizing scientific findings. As I mentioned, that's the kind of, when I was looking at Khan Academy's problems, what I then sort of turned to was thinking, of all the sort of research finds I've read and work on motivation and work on asking Socratic questions and other areas, what might work really well in this context? And so one thing that really jumped out was teaching this growth mindset of intelligence, as I mentioned before. So this is kind of now the experimental part of that kind of research that I have previously mentioned that has a huge effect. And so in terms of translating this into something that could help Khan Academy or do an experiment that actually might be effective for students, the idea was we take the original version of exercises, which I'm going to call the sort of practice as usual exercise, and now we're going to compare that to a growth mindset exercise. And all we do for that is very simple. Add a message that says something like, remember, the more you practice, the smarter you become. And so this is just stuck right above the exercise. And so this message is encouraging students to think that, well, the more you work at something, the smarter you get. Intelligence is malleable, so your effort is actually going to improve. And so now, in terms of the experiment, what this means is to test this question about whether it actually helps. We have, let's say, if we had 1,000 students, 500 would get the practice as usual exercise, and then 500 would get a growth mindset message. So as they're working through these sites and they move from problem to problem, these students just see everything as normal, whereas these students are seeing different messages. And so remember, the more you practice, the smarter you become, or mistakes help you learn. Think hard to learn from them. And we had a bunch of messages like this. And so this is work done in collaboration with Joshua Solikstein, who's at Khan Academy, and also at Stanford, Dave Paunesco and Ben Haley. So as I mentioned, I can't show the actual results in a public forum, and we're sort of still processing it. But you can see the kind of data that we can get from this. So we actually get about 50,000 students per condition. That's what we anticipate. And so now we can look at the number of problems attempted and ask, well, in this practice as usual, how many problems do students attempt? In the growth mindset message, how many problems are students attempting there? Is it going to be higher, or is it going to actually be lower? We can also look at accuracy. Maybe there's no difference in accuracy at all. Maybe it's higher, maybe it's lower. And so this is something where now we can actually test, not just say that there's research supporting the idea that you should encourage a growth mindset, but actually get evidence with real students, even students from your classroom if you were involved in this kind of study, about whether this is making a measurable effect. Are they actually doing more problems or getting more things right? Are they learning more deeply? Now, one thing you could say, let's pretend we did get effect. Let's say we found growth mindset messages were helping. Well, you might be a bit skeptical there. Did we need 30 years of research by Carol Dweck and many other brilliant people to figure that out? Or is it kind of obvious you can just give someone a message that's encouraging? Well, that's why we also ran another kind of version of an exercise. And so this one, we add positive messages. Now, it's kind of a subtle difference, but a positive message is just encouraging. Some of these problems are hard, so do your best. Now, if you compare this to a growth mindset message, they're similar because they're both positive and encouraging. And they're both meant to motivate. But this one is just telling someone that they should work hard, or the other messages were just saying, you can do it if you try. The growth mindset message targets a very specific belief. When intelligence is malleable, intelligence can be changed. So when you work hard, you get smarter. So now, what we can do is, again, compare not just two conditions, but actually three. And see, well, which one is better than the other? Are these better than just normal? Is this better than that? Is this better than that? Or is there no difference at all? Now, in truth, because we know about students on Khan Academy and online learning, we actually ran a bunch more conditions, and we can run many more. So these are the main ones to think about. And so as I mentioned, we can see, do students attempt more problems? Does their accuracy and learning actually change? And this is going to help us really pick apart whether it's really important to target disbelief or some of the positive messages. And I think this is really important because you might imagine that these messages could be pretty similar if you were to ask teachers or parents which one they would use to motivate their children. Maybe they think either one will be equally effective. But if they're not, that's actually going to be pretty significant. It's also worth noting that it's not just relevant to Khan Academy exercises. It's the kind of finding that can be relevant to students in a math classroom. So when students are struggling through a hard problem and the teacher's in front of a class, what kind of messages does she say to them? Is it helpful when you're giving feedback after a test to write things like, you can do really well next time if you try harder? Or is it helpful to say something like, you didn't get these things right, but if you try and understand what's going on, I know you're going to get smarter at this kind of math. So there's actually a lot of implications that can be spelled out. And these are things also that could be experimentally tested. As long as it's done with an online resource, it makes it really easy to improve and test many of these ideas. So again, just to give you a quick overview, the kind of approach I mentioned is that I tend to take is find some quantifiable outcomes in the online resource like Khan Academy math exercises, synthesize recommendations from research, and do an actual experiment that tests these. I've just shown one example here. There are many others that could fit in, and I'll actually move on to some of those now. Any questions before I move on? Okay. So I'll try and, in this section, I'm going to try and review some work on how can we actually increase learning without changing the materials. So hopefully this doesn't sound like a snake oil scheme, right? How can you improve education without actually making any changes to the materials? Sounds like a scam, right? Well, the idea here is that you do have to change something, but we don't necessarily have to change curriculum content. The idea here is, can we promote reflection by asking students Socratic questions that really make them reflect on what's happening? And the nice thing about questions is they're really easy to insert or add to material. And they're also something where it can be easily taken for granted. Like we may, as a teacher, you may know what questions students should be asking, or you may know how to help guide a student through thinking about a problem. But they may not spontaneously ask questions or stop and reflect. The really nice thing about online learning is it's easy to embed these questions. So even though it's not a real human being asking them, you can still prompt them, and they may respond when something pops up, or when they provide the text box for them to write into. And I think this especially might be important if there are concerns that online learning might lead to shallow learning, because students can kind of passively just sit there and watch a video. This is the way to engage them in thinking, helping them construct their own knowledge. But it still leaves a big role for the teacher, who can then help choose the questions that are asked and figure out which kinds of questions are most effective for different students. So I'll talk about three kinds of questions. And I'm just going to talk, again, given the time, at a general level, but I'm providing references that can point to more specific version. So let's imagine, again, we have a video or an exercise. What are questions we can ask before people come across that? Students come. What are questions we can ask while they're watching a video solving an exercise? And what are questions we can ask after? And so these actually align quite closely with things like assessments, tests, or quizzes. But testing has a pretty bad reputation, right? It's quite controversial, hot button issue. You can just open up the newspaper. I think I saw Diane Ravich's some pretty recent articles on it. Now the idea here is that we're not using a test as it's typically used to assess and say how good or bad a student is. We're actually using a test to help students learn. Because sometimes just answering a question or trying to solve a problem can actually help you learn. And I'll talk about that research. So now, one thing I think that's worth kind of framing in terms of thinking about the kind of point of view I've got from thinking about cognitive science research and the findings I'm about to present is that I've realized that there's this kind of persistent misconception I have where I think of learning as just adding to what I know. It's almost like I imagine that when I learn some new content, like a video about chemical reactions or math exercise, it's almost as if I implicitly believe that learning is just a matter of adding this object to a bucket. I pick it up and I drop it in my head. Now, of course, I'm not going to. I won't say that I actually believe that. You know, I think it's a much more rich process. But I keep, when I'm teaching and when I'm learning, I keep acting as if I've got this kind of implicit assumption. And I think this actually kind of underlies a lot of what we do, even without realizing it. When in fact, based on experience in classroom and research, learning is a lot more like integrating. So you've got this information, like watching a video about literature or doing a writing assignment, and the knowledge you get from that, you've actually got to integrate into your mind. And it's a lot more like integrating a web page with the internet. So you made a new web page, like this content, and you add it to the internet. So this is a bunch of websites linked. There are a couple of steps. One is, well, when you add it, you've actually got to link it to what exists already. If you just post your website, if I post a random website on my domain, who knows about this? It's got to be linked in some way, like it's got the site of the website, and in this analogy, I would say it's linking new ideas to prior knowledge. And also, you've got to put the right kind of content in there so that when people are searching or coming across it, they're going to see how it's related. So that's where you've got to encode something deeply. Now finally also, you've got to think a lot about the search process. Because once you add something to the internet, it doesn't even matter what's on the website unless it's going to be accessed by people when they go looking for information. And so again, this really ties into the idea that when we learn a new fact or we want students to understand how to solve a problem, we really have to think, well, how are they going to be accessing that later? Is it that they're just going to have to remember it for a standardized exam in 2 weeks and then forget it? Is it that they're going to have to use it to solve a different kind of problem? And so every single time we think about a learning episode, we've actually got to already be thinking, well, where are they going to use this information and how are they going to access it later on? How might they be tested on it, or how might they have to apply it? And so in that kind of model is much richer, and it helps to kind of understand the findings I'll talk about now. Okay, so maybe I'll start moving forward a bit quicker here, but I'm going to sort of flash this content, and you can put whatever kind of content you care about. Maybe you teach literature, maybe you do math, maybe you do chemistry, but whatever kind of video, online video, or piece of a textbook you use, just kind of imagine that there. Now, problem-based learning, the idea is instead of just presenting people with this lesson, you would first think, okay, can I ask questions before they even start that's going to help people link this knowledge to what they already know? So the idea here is, let's say you were teaching students about how to calculate the standard deviation. Instead of just telling them all about that, you would first get them to think, how do you measure variability? Or if you see the bus and it's supposed to arrive at 2 o'clock, and sometimes it arrives a bit earlier, sometimes it arrives a bit later, is there a way you can measure whether that bus is mostly on time or totally erratic? And so this is actually framing a problem for students to solve. And the knowledge that you present about standard deviation can then be interpreted as a solution to that problem. So students can actually see how this relates to what they already know and how this relates to possible problems they're going to have to solve. So that's one kind of way of adding questions before they even come across content that can help. Now another is actually during learning. So if you're teaching a student or giving them a lesson and you stop them to start asking them questions, they might feel a bit cheated. I mean, they're here to learn from you. That's why they came to school. So why are you asking them questions? But again, that's kind of an attitude that's more in line with thinking that learning is just like dropping information into your head. Actually asking questions like, why did the instructor say that? Or why is that the right answer to the math problem? How did you figure that out? What are you thinking? What's the next step in this solution, or what's coming up in the video? These can actually be pretty powerful in terms of helping learning. And this is actually the research topic I focused on the most, which is explanation learning. And I'll just briefly sketch this, but the kind of work I've done is looking that does asking people to explain just provide a general boost, like making them more engaged or pay attention, or does it selectively guide learners to look for patterns? And so the theory I proposed and tested was that when you explain why a fact is true, it forces you to interpret it in terms of broader generalization. So for example, if you think of telling a student 2 times 3 is equal to 6, if you just tell them that, they can memorize it. But if you ask them to explain why is 2 times 3 equal to 6, they might have to push on and come up with some kind of statement like, well, it's because multiplication is repeated addition. So now, that's not just memorizing a fact, that's actually interpreting the fact in terms of a broad pattern or generalization that applies to all kinds of problems involving multiplication and addition. And so I found evidence for this in a couple of papers. I also found that explaining why can help students use the knowledge they already have. Whereas if you hadn't asked them to explain, they just won't have access to it at all. And what's interesting is you kind of see an explanation, it's not a silver bullet. You kind of have to know which questions to use and when. Because if you ask someone to explain why, they may sometimes overgeneralize because they'll ignore an example because they're looking for a broad pattern. So in terms of thinking about adding questions after learning or after some content, often you might imagine students do a bunch of lessons, and then they get tested. And this is just for assessment. But again, the idea here is, how is an assessment an instructional tool? And this is research on the testing effect. And this is a great paper, a chapter in a book by Rudiger, and it's on 10 benefits of testing. So how testing can actually help learning. Again, it's a polarized issue. This is not testing for assessment. This is testing to help learning. And this could align nicely with ideas about formative assessment, although those often focus a bit more on giving students feedback and giving teachers feedback, whereas this is actually just testing because it helps students access knowledge. And so the kind of experiment that's done here is, well, if you learn a video, let's say about your favorite British author, or you watched it, is it better to watch that video again, or watch a similar video? Or would it actually be better to be tested, or to be quizzed? So you'd have to say, well, what are the key ideas in that video? Or what did you learn that was new? Now, what's interesting is right away, it could be better to study it twice than to study and do a test. But actually, if you just wait after some delay, or a week, studying twice is not as good as studying and testing. And this is just odd, because when you test, you can't remember everything, so you're actually learning less than if you study it twice, right? Or it's strange to think that being tested could be more effective than having someone lecture to you again. But actually, that's what has been found in a wide range of situations. What's interesting is learners think that studying twice is better than studying and testing. Now, it's going to depend on the details and materials and the kind of test. But what's interesting, the very same studies where studying twice was worse than studying and testing, learners thought that studying twice was actually better. They weren't even aware of it, because there's such a robust intuition that being able to have more time with the material is helpful. So I think I'm going to accelerate quickly here so we can have time for questions. But in terms of questions after, another really interesting effect is called the mixing effect. And the idea here is that, again, you might think, okay, I learned topic 1. Let's say it's first topic in physics. Then I get a bunch of tests on it. I learn topic 2, a bunch more tests, learn topic 3. This is what a textbook looks like, right? And math textbooks. Now the mixing effect says, we don't want you to change your curriculum materials, but we want you to change when you put the tests. So now actually I just get one test on topic A, but then after in topic B, I get these mixed together. And then topic C, I get them mixed together even more. Now this has had a huge effect, work by Doug Rohr, huge effect. And what's interesting is it doesn't change how much materials there are. But the reason it's so effective is because students can't just memorize, oh yeah, they're testing me on this because I just studied it. They've actually got to figure out, well, what's the difference between these problems and what's the key principle that I really have to apply to solve them? And so again, it really helps not just with them having good memory, but actually in them really getting deep understanding and really being able to grasp the core concept and using completely new situations and solving new problems. Okay, so in terms of reviewing there, I talked about how we can think about adding versus integrating knowledge, and then questions before people learn, questions during learning from a video exercise, and then questions after. And I have a lot more information here, a lot of the papers I cited. Any questions at this point? Okay, so this I'm just going to skip through, but the idea here is, can we teach learning strategies? Instead of spending a lesson teaching a single concept, could we spend it teaching a general strategy? Now in general, it's been really hard to do this. But I think online learning is promising because you can take a lesson and just refine it till it gets really good. And because also online you can repeatedly reinforce students in questioning themselves or forming new behaviors. And the experiment that I'm running now is about teaching self-questioning strategies. And so again, it's on Khan Academy, where students are told about the strategy. And they can ignore that if they want, but if they click on it, they'll be told a bit more about what kinds of questions they can ask. Also, we just embed inside of the hints these questions, like you're solving it, you see a step like this, and then suddenly this pops up. Well, why is what you're doing helpful? Or why is it useful for your goal? And this can happen in a bunch of different exercises. And these are just some examples of the prompts that might be given. What, why, and how. So they're sort of taught, ask yourself these questions while you're trying to solve a problem. Now, the final line of work that actually combines previously what I've talked about is, let's actually make small video lessons, and I kind of demo this in this kind of learning assistant idea, which is something I'm under development with collaborators at Stanford like Daniel Green, where you give students short 5-minute videos that teach them a growth mindset, and you give them guided questions that help them think of how they apply it to their everyday life, and also self-questioning strategy. And now the interesting thing is you can actually do experiments where we give some students a growth mindset video, some students self-questioning, some students get nothing, some get both. And then say over a long period of time, like a few weeks or a semester, does that actually influence grades? Okay, so in terms of finishing off, I think a big thing about these online education resources is it makes it really easy to gain collaborations between scientists and educators, because the internet removes barriers to communication. If you simply send resources that you use to someone else, they can give you comments on what might be changes. Researchers can speak with teachers in a kind of common forum. And one thing that I've been developing at Berkeley is what's called the Learning Education Research Network. So this is when I was at Berkeley and before I moved here. And the idea is, how do we create a virtual community, which is just basically a website, a mailing list with people from different backgrounds. And there's a discussion forum, so someone can just email out to the mailing list a question about, I'm using this math exercise in my class, are there ways I can improve it? How do I get my students to pay more attention? How do I get them to give up less easily? And people can then give a bunch of answers. And the nice thing here is that because these answers sort of stack on top of each other, one person says something, someone else can disagree or agree, there can be this collaboration. Even better yet, if you have a concrete online product, like an actual video, people can just look at the video and add comments in something as simple as a Google document. And even though the technology is very simple, that successive act of someone making a comment, people adding on top of it, on top of it, on top of it, is exactly like what makes Wikipedia so good. And then all these different ideas can actually be tested by researchers. So if you are wondering, well, how do you know when it's a good time to partner with researchers? Or are the lessons you use or the context you work in, is that something that you could do this kind of research to help your students directly and sort of iteratively improve some online resources to make them really high quality? Well, here's some criteria I've tried to pick out that I found helped. For Khan Academy exercises, I think they satisfy these. I think the video lessons in an online course do as well. But the three criteria, which you can remember, I think, repeat. It's realistic, so it's not something from a lab. It really has to be a product students are using. It needs to be allow experiments. So by experiment, what I really mean is you can show someone two different versions of something, two different versions of exercise or video, because that way we can figure out if it's actually helping. And teachers experiment all the time in their classrooms. It's just that we don't normally do it in a way that we collect data for students for each different version, but you try different strategies. It has to be a product, and again, this can be a free product, but by that I mean it's a self-contained thing that you can give to someone. It has to have some kind of evaluation, again, not to sort of say someone's doing something right or wrong, but just some measure of learning, so we know that what we're changing can actually have an effect. For example, videos don't always have a good measure of learning, because you're not sure if students learn from it or not, but exercises do. Accessible, you can just put it online, give someone the URL, and that's as easy as that. You can make a super high quality resource available to anyone. And at least for me, I think it's helpful if it's theoretically motivated by past research. And that can be done in conjunction with teachers who've got a lot of past insights about what works well. And again, I think the really key thing is repeat. You're not going to build a perfect resource your first time around. And if we spend more time improving resources that already exist, that might be a lot more powerful than creating new ones. Great examples of people who do this. There's this Ed Lab at Columbia, and of course organizations like Intercall that play a huge role in bringing together this kind of collaborative work. Okay, so just as a quick review, I think I talked, there's a lot there, sorry about the fire hose, but I'd say the key idea is maybe some of these ideas would be useful in the future when you're building resources on the class about applying cognitive science to online learning. I talked about a couple of different issues, and also provide some resources to like pointers to other papers that you might revisit. As I mentioned, these slides will always be here. And also, maybe it's worth thinking what kind of online collaborations might be good between science educators. How can we sort of have a dialogue that takes place over the internet asynchronously that's really convenient for everyone? You just sort of comment when you have time. And are there cases where we could do more research? Because scientists have their own interests and focus. So if educators can make it easy for them to do their research at the same time as improving resource, then that's helpful. And of course, vice versa. Scientists, if they can do research that's also practically beneficial and not just in line with what they're currently doing, I think that's going to make it a lot easier to make those connections. Any advice and questions you have, please feel free to send them to me. I'll be happy to hear. It'd be great to get people's thoughts. All right, so thanks so much for
Thank you so much, Joseph. This is wonderful information and definitely timely, considering all the growth in online learning and blended learning, for that matter, in our community. There were a few questions so far. Please, if you haven't asked your question already in the chat box, go ahead and do so. But I'm going to go ahead and read you some of the questions that we had. Paulo Lynn asked, is anyone creating online learning that allows the student to select a version of the course that teaches to his or her learning style? And Joseph, if you want to talk to that, please do.
Yeah, that's a really good question. So I guess there are a couple of components. One thing I think is that we're not so sure about how to characterize learning styles. So when we say learning styles, do we mean like auditory or visual learners? Because it's been really hard. If you go and actually, one thing I didn't mention, if you go to scholar.google.com or just Google Scholar, this is like the instant litmus test. If someone suggests an idea, just go to Google Scholar, plug in the keywords, and if a journal article comes up that links to that, well, then you've got a way to assess it. If you go to Google Scholar and type in learning styles, there's actually a recent paper, Perspectives in Psych Science, that says that there's actually been hard, at least for visual and auditory. People haven't figured out exactly how to characterize those in a way that seems like there's evidence that if you take a visual learner, at least the way it's been defined, and show them one kind of instruction, it's going to help more than another. So I think that's kind of a challenge. And more generally, it's just been hard. Is it that fixed versus growth mindset learners are different learning styles? Or is it that some people are more or less independent? I think that there's not that much work that sort of figures this out really well. But I know there's definitely some people interested in. The other component of what you said that's really interesting, though, is giving students choice. Because, we talk a lot about adaptive learning and, there are big pushes by people to focus on automatic instruction. But students, sometimes they don't know how to assess what they're learning. But they do know they definitely have information about it. So a nice combination of having teachers provide suggestions and getting students to make choices might be a really effective way of customizing instruction. And at least when I think of things like online courses, that's not so obvious. I think on Khan Academy, they do actually give students a lot of choice in terms of they can choose whatever video they like or whatever exercise they like. I think Khan Academy just rolled out a new learning dashboard that gets recognition with Khan Academy, but also gives students the option to choose.
Thanks so much, Joseph. Also, another question from Kim Thaler about where these results are published from your work. If you could go ahead and give us some indication on where we can find published results from your work.
Okay, so these studies on Khan Academy that I haven't shown data for, those are not published yet, so I don't have those in format. But in terms of all the other papers I talked about, like, for example, adding the questions, you can, I think that references is probably the easiest place to start. georgians.com/education. That website also has papers that I've written. This one is a nice one, I think, for overviewing. The empirical results will be on josephjones.com/papers. And this will be results by other researchers that, growth mindset and testing and so on.
And in terms of the Khan Academy results, when do you see that being published?
Yeah, that's a great question. Hopefully soon, but it also depends on the collaborators and what the timeline is like. And we're also trying to do a bunch of different analyses to see, to be sure we can be confident about the conclusions we're drawing. That kind of thing actually, if there are teachers or people who use math exercises in their class and would like to do experiments with online exercises, I can easily reprogram a Khan Academy exercise in any kind of survey software. So we can, if you want, we can publish them using your class.
Great. There was also a question from Diane Mace about your comment on self-questioning and whether or not that's a metacognitive strategy.
Yeah, that's a good point. That may not be the best way for me to characterize it. I was thinking of it as metacognitive in that when you ask yourself questions, it could be more aware, it makes you more aware of what you don't know, and also that students may not be aware that actually asking yourself questions is helpful. But what's traditionally thought of as metacognition, I think, would be more things like planning. How are you aware of your process for planning how to solve a problem or planning how to allocate your time in studying, and also whether you can stop and assess your knowledge and learning.
Perfect. There's time for one more question if we have any takers. And there's a question from Paula that just came in. Which university would you recommend for learning the development tools for online learning?
Okay. Thanks. So actually, if you want to know tools for online learning, well, on my website I have a link to a few that I found useful. So that's, if you go to josephjones.com, it's like useful software for e-learning or something like that. EdSurge, I guess let me say it this way. I find, this is my opinion, but I find it most helpful to look for things that don't require much programming because you can do a lot of things pretty quickly. So for example, Qualtrics, it's a survey software that most universities have. Extremely great for doing all kinds of online learning materials. If you Google EdSurge, EdSurge, EdSurge is a sort of Bay Area aggregator, and they do an incredible job of having a near comprehensive listing of all the online learning software out there, all the things that are being used to develop for K-12. And so they would be a great place to start in terms of just having a nice wiki on what's there, and they even have links to which ones are free and which ones you can try out. Corporate training conferences, it's a very different field, but they've actually got tons of development in terms of providing tools for e-learning. So if you were to look up e-learning guilds or DevLearn as their conference in October, I went there last year, and in a half-day expo, I learned a huge amount about what is out there. So looking at what's in the expo, you could look at some of those. I think Easy Generator is another one that I found was useful. You can also see that on the website, on the website links I have. I'm not sure if there's a necessary university that would point you to the best place. I found actually you'd be amazed at how much you can learn on Google. If you are proactive about searching for things and then figuring out, okay, who knows a lot about this area and can I follow what they're doing? I found that's at least how I've I found is the best way to figure out how to learn a lot about our field. And that's probably the best way to find out which software is the most relevant to what you're doing. Conferences, yeah, are also a good way because then you ask tons of people questions. And if you have questions, feel free to email me, please.
Well, thank you so much for your time again, Joseph J. Williams. We really appreciate it. This has been a wonderful first start to our research and review webinars for this fall. We will be sending around the link to this archived webinar so that you can listen to it again if you missed anything. And again, thank you again to Joe. And we will be back next month with another webinar for you, and an evaluation link will be sent to you via email as well. Thanks again and have a great afternoon.
Thanks everyone. Bye.